Hello, Synapse community. My name is Ryan Majitimer, and I'm a product manager on the Azure Synapse Analytics team. Today, I'm joined with Kalyan Kadiyala, and he is going to talk about our new dedicated SQL pool connector for Apache Spark. Now, I know what you're thinking. Didn't we already have a connector for Apache Spark and dedicated SQL pools? Yes, we did. And we've got some big improvements. I'm going to hand it over to Kalyan to introduce himself. Welcome.
Thanks, Ryan. Hello, everyone. I'm Kalyan Kadiyala, a principal software architect on Azure Synapse Analytics team. The Apache Spark connector for Azure Synapse dedicated SQL pool enables efficient data transfers at scale between Apache Spark runtime and Azure Synapse dedicated SQL pools. In this session, we'll be going over the release highlights for a release made on March 21st of 2022. The release introduced new set of write API capabilities along with significant improvements to the end-to-end write throughput performance. So with the new features now, users can perform different kind of write operations like overwrite data in an existing table, append data to an existing table, or choose to satisfy a requirement where you already have a data in an existing table, and when you submit the write request, you don't want to cause additional data changes. If you use error if exists, the request will abort, but also will return an error back to the callee. If you don't want an error returned back and simply ignore the write request, you use the save mode option, ignore. So moving down the list here, our internal tests indicated at least 15x to 20x performance gain over the previous versions of the connector, which means as you start to consume the new connector updates, you should start seeing better end-to-end write throughput performance in your existing workloads. The last one is an optional callback handle on the Synapse SQL method. It's a Scala function that users can pass to receive post-write feedback metrics. The metrics are both quantitative and descriptive. So you can use this information to build better control structures, like if you are sourcing data from multiple different disparate data sources with the same schema, for example, and writing to a same target table, you can build an iterator over those collection of data sources and continue to advance in your write as long as you are successfully completing each of those requests. Or for example, you can use the same information, the quantitative information, to run repetitive tests and establish worst case, best case scenarios for your given data ingress scenarios. Now, here is a high-level data flow. In case of an internal table type, data is first staged in Parquet format in a temporary folder, from where we use a copy SQL command to move the data into the target table's location. The copy command is more performant over the previous use of CETAS with CTAS approach. In case of an external table type, data is directly written to the target table's location using the user-specified data format, which is Parquet or delimited text. And then finally, the external table is recreated on top of the data set. Now, here are the two code samples. The first one is more of a very verbatim and most commonly and widely used implementations by the users, where, for example, what I'm trying to do here is I'm trying to read data in Parquet format that is stored on some ADLS Gen2 path, and I'm trying to write to a target table. The second example is more about showcasing the new features that we have added, where, for example, as a user, I'm trying to write a source of data and write to a destination table using an append save mode. And I'm also asking the connector to send me back the post-write feedback metrics. All I'm trying to do here is print those information to the console. Now, here is the performance numbers. The dataset construct here is a public dataset available on Azure Datasets portal. It belongs to the NYC Taxing Limousine Commission trip data, all of 2009 data. The data is about 6.6 GB with about 170 million records, where the width of a row is 23 columns. Data is stored in Parquet with snappy compression. So the resource capacity here is considered based on the data set that I have with additional wiggle room that is necessary to address any spikes, right? Now, the performance numbers that you see here indicate that the new version is at least 15x more performant than the previous version, where the previous version took about 52 minutes and 14 seconds to write data into a new table, whereas the new version completed that same request in 3 minutes and 37 seconds. There is no comparison to the other save modes because there's no provision for supporting those save modes on the older version. You have the numbers here, relative numbers here. In case of overwrite, we delete the existing data and then ingest the new data into it. Hence, you see a spike here in the overall completion time. Likewise, for the append, it's more close to writing to a new table. In case of error if exists and ignore, it's a fail fast response where since the target table is already present, the request aborted and completed much earlier. Let's now do a brief demo of the new features supported by the WritePath API of the connector. So here I've set up a notebook where I have different scenarios of write. For example, here's the default scenario where it uses the error if exists save mode, tries to write data from a Parquet data set into the target table. Likewise, as other scenarios indicate intent to overwrite the data, append, ignore. And there is here one scenario where I want to receive post-write feedback metrics and print the information out to the console. And the last one is error if exists, which is if the target table exists, abort the request indicating the reasons for it. So let's run all of them in sequence. As you see here, our request to run all the cells in sequence by using the run all command here has successfully completed, printing out the execution times that each cell has consumed to finish the write request. As you see here in the last cell, the end state is a failure because the target table is already present. If this were to be a cell anywhere on the top, subsequent cell executions would also have been cancelled.
The new dedicated SQL pool connector sounds like a giant leap forward. What does this mean for people that were using the old connector?
As you see, the signature is fully backwards compatible, as shown in this first example here. If you, however, have a table that is already present in your destination database and you're trying to write data into it, make sure you pop in the relevant save mode option on it. Otherwise, your request will fail, indicating the table is already present and the request cannot be satisfied.
These improvements immediately make me think of data integration. What should I be aware of when I'm setting up my pipelines with notebooks?
In order to use pipelines to run your notebooks, ensure the workspace manager identity is also granted storage, blob data contributor access so that the request can successfully write to the temporary staging folders and copy the data into the target table using the copy command.
Well, that wraps up our video for today. Thank you, Kalyan, for joining us. Let us know in the comments if you're using Spark and the new dedicated SQL pool connector. Again, my name is Ryan Magitimer. If you want to find me on Twitter, it's rmagitimer. If you want to find Synapse on Twitter, it's Azure_Synapse. Like, follow, subscribe, share our videos with your friends. Thank you, and we'll see you on the next one.